Okay, now we are recording. Good. So today we're going to talk about the next step in the work of a data scientist, and that is data acquisition. Okay. So let me remind you about the steps of the work of a data scientist. The first steps, as we talked about in the last lecture, is to define our data. And the second one is acquiring this data, also known as data mining, okay? Let me remind you our test case. We said that I want to predict the outcome of an election, okay? In a more precise and inexpensive method than polls, which are the gold standard today. And social networks are a really huge deal. So we want to use that data of the social networks as a basis for our prediction, okay? And this is, of course, an enormous amount of data that envelops many people with a gamut of opinions. And if we succeed in working with this data, we will have a better, more precise and cheaper alternative to polling, okay? So obviously we'll have an advantage, an economic advantage over polling companies, okay? So we will get the contract with our clients, which are the political parties. So after we define the problem or the hypothesis that social networks data represents accurately the public opinion and might serve as an alternative to polls, once this is done, once defining the problem is done, our next challenge is to build a smart system that can communicate to other systems online, access this data, download it, and build a data set so we can analyze it. This stage is called data acquisition or data mining, and it's very exciting. Since sometimes, and we will see it later today, we have to duel with the smartest people in industry that don't want us to get this data in order to obtain this data, despite their unwillingness to share this data with us. So this is a critical stage because it requires sharp hacking skills and out-of-the-box thinking. And this stage, data acquisition, is what sets the difference between a good data scientist and a great data scientist. The quality and the quantity of the data that he or she is able to acquire, okay? Now, as I mentioned, I'm very fond of the data acquisition phase. And the truth is that not everybody teaches it. This is not something that is commonly taught in data science schools. This step will allow you to more likely reach data that others will not reach, okay? And this will, of course, give you an advantage over other data scientists. In the previous lesson, we presented an example of an alternative to election polls. In fact, if we were working with Twitter, we would make life easier for ourselves, right? Twitter makes information accessible easily. But it does not give uniqueness for us, or an advantage for us, because everybody else can get this data. So therefore, instead of Twitter, we want to base our data on Facebook. The process of acquiring data on Facebook requires higher skill. Why? Because Facebook, we should no longer, by the way, we should no longer say Facebook, right? We should say Meta, because Facebook is Meta, right? So let's not call it Facebook. Meta does not encourage data download, but the effort on our side pays off. Okay, because this is not something that Meta wants us to get, so other data scientists will go to Twitter, and if we go to Meta, we will have data that other scientists do not have. The interesting and unique data that is there, if you want to download it, you have two methods, okay? An easy method and a hard method. And we will both learn in this class, okay? In this course. The first method, the API, let us go into the house, into the website through the main door. Okay, this is a direct download of the data through the processes that the owner of the website defined for us. Okay, and the second method called crawling, okay, is a complex way of obtaining data. It's like going not through the main door, but through trying to find an open window and going through that window to get the data. Okay, it's kind of like what a burglar does in a house. Okay, we don't break anything, but we look around and we try to find an open window that we can get through and get the data that we want, that the owner of this website does not want us to get. And the crawling process, it's fun, to be honest. It may be naughty, again, to be honest, because basically we invite ourselves to a site that didn't invite us. They don't want us to get in and get the data. So we download the data from it, even though the owner of the site doesn't want us to get the data. So this is a lot of fun. And again, this is slightly naughty, not illegal. We don't do anything illegal because, again, we don't break anything. We do not hack, but we do try to find open windows to get through. Okay. So today, the class today is about API. And in the next class, we will talk about crawling. Okay. So let's look today at some cool ways to get the data. I believe you will find this very useful in many contexts, such as how to scan a site for the best tickets for performance abroad, okay? Or how to get, let's say, the best deal on hotels or apartments or whatnot, okay? So we have to do 3 steps: planning, acquisition of data, and saving the data. Let's imagine that you won the lottery and you have a large sum of money that you want to do something with it. Okay, you don't want to spend the money on a yacht or on a super expensive car and whatnot. You want to invest it wisely. Okay, so you decide to buy a small apartment, one that you can rent to others and make a profit. Okay. So what's the problem? Unlike data on apartments for sale, there is no neat and accessible information on rental prices by dividing into cities and streets and neighborhoods in the country. But we are data scientists, so we want to get data that is hard to get, right? We don't want to. We have an edge over the common people that do not have the skills to get to get data that we do. So we want to use this edge to get the best deal that we can, meaning to pay the least for an apartment that we can rent out for the most amount of money. Okay, to make a better profit than the average man can, or the average woman can. So how do we get started? The first thing, again, is what data do we really want? To get full answers, we need to ask ourselves, this is the first question that we need to ask ourselves: what is the data that makes most sense for us? In this case, the answer is relatively simple, right? We want data like the area of the apartment, the city, the neighborhood, the street, the cost of rent, obviously, number of rooms, the floor which it is in. Does it have an elevator or not, or more than one elevator? Does it have parking? Okay. What does a person want? What the person that wants to rent the apartment from us want? You want a ceiling over his head or her head, air conditioning, and let's not forget something very important. What's the date of the publication of the ad. Why is this so important? If we get ads from the last 10 years, including the date, then we have a solution in our hands. Why? Because we can spot trends of price increases. Okay, we can see which streets, which neighborhoods, which types of apartments increase their value in terms of the rent the most in the last 10 years. And we can buy the ones that have the highest trend. So we know that, or we can predict that the price for rent will increase in the next 10 years as well. In such a case, we will make, this is the best deal for us because we're buying relatively cheap apartments and we will rent them for the highest price we can, right? So we make more money. This is our edge over the common people. Okay? Any questions so far?
No questions.
No questions?
No questions.
No questions. Very well. Good. So now let's narrow down a bit and focus with the table on 10 really important characteristics that we must include. Okay, so obviously the city is very important, the area of the apartment, the date, as we said, the neighborhood, the number of rooms, okay, as I said, the floor, how high it is, if it has an elevator or not, this is very important. Number of apartments in the building and private parking, and of course the rent. These are the features. Okay, these are the important features. As you remember, we said that a data frame has columns and rows. So the columns will be our features. Remember the name features. This is very important. We will use that name features many times. So the columns represent the features of the apartment that we want to check, or all the apartments that we want to check the ads for. And the rows in our table will be instances of advertisement, of ads in the website for apartments for rent. Okay? So these actions, deciding what are the features that we want to download, are exactly the first step in data acquiring. Okay, we need to define exactly what data we will need, what data we want to have in our table to be used for analysis. Okay, so this is the table structure for this task. This is the table that we want to get. Now we have a research question that is, in our case, finding a worthwhile apartment for investment, or the best apartment for investment. Which apartment is the best for investment in our case, in the budget that we have, the money that we won the lottery. Once we have decided on the desired structure of the table, now comes the stage where we will need to run our magic and get the data. Okay? Now, as I mentioned, in order to acquire the data, we can use our two main methods. The API. API is an acronym for Application Programming Interface, and crawling. Let's expand on that. So an API is a pre-designed interface for data acquisition. It allows relatively simple access to data of entities interested in exposure. Okay? Therefore, these entities encourage easy access. They want us to use their data for whatever reason. Okay, a classic case of such a thing is as I said, Twitter. Okay, many times the really interesting data is not the data that this entity has prepared an API for. Okay. Even if there is an API for this site, it doesn't mean that we have to use the API. And sometimes to get the really interesting data, we will have to use the second method and build a crawling system or a crawler, a web crawler, okay? But in many times, the API is sufficient for us. Okay, it depends on the data that we want and how this data is accessible to the public by the owner of the site or the entity. Before I teach you about the two methods, API and crawling, it is important to remember that at the end, the data that I acquire, I will want to save for the purpose of the research and analysis, right? So there are many accepted formats for saving data in a file. We will discuss two formats, either as a CSV file, okay, on the left. We can open CSV file in a Notepad, for instance, or in Excel, or as a JSON. JSON is a JavaScript object notation. And after acquiring the data, we will save it in one of those two formats. Of course, there are other methods for storing data, for instance, databases. However, for the purpose of this course, we will focus on these two data storing formats, okay? So CSV format is for simple tabular storage of data. Working with CSV in Python is easy and simple. For our purposes, it is good to know that it is easy to load the file and turn it into a data frame, as we've seen in the last session, in the last lesson with pandas. CSV represents the acronym comma separated values. And as its name implies, it is a text file in which the fields are separated by commas, as you can see here, okay? So we have a date, a country, units, and revenue. So if we take, for example, this sales report, okay, we can easily see that the data is stored in a way that for each instance, we have a date, a country, how many units are sold, and the revenue. Okay, and they are all divided by a comma. Okay. So, as I said, working with the CSV or comma separated values is easy and simple. Okay. Pandas, as we've already learned about in the previous lesson, and also there is a library called CSV. Which is another library that can open and manipulate CSV files. Okay, CSV files, of course, can also be opened in a good old Excel software. If you choose to do so, the file will look like this on the right. Okay, and let's talk a bit about the pros and cons of using the CSV format. Let's start with the pros, with the benefits. Keep in mind that this is a text format, and therefore it's relatively lightweight. Okay, there is not a lot of unused data on that or overhead. So that's one advantage. CSV allows importing and exporting large amounts of data. Okay, it is a format supported by most systems and platforms, and also it's a tabular format that is easy to handle and organize. Okay, it's easy to read it into a data frame and organize it as a data frame. Now to the cons or the disadvantages. CSV is not intuitively readable. Okay, if we read it, if we open it in Notepad and read it, it's not very intuitive. The data is in the format that is represented by one level and not hierarchical. Okay, we cannot have more than one level. And sometimes this format is a bit spoiled in the way that it requires special care for the use of entries that contain special characters. And when I'm saying special characters, I'm saying things like comma, quotation marks, semicolon, and so on and so forth. Suppose that, for instance, let's suppose we acquire data that includes addresses, for example. Let's say addresses of colleges and universities, okay? Like this university or your universities. As part of the data, we can expect the address to have comma in it, right? Let's say this institute is in the address of this institute is Golom Street, 52 Golom Street, comma, Holon. That's the name of the address. So we will have a comma in the address, and this is very common. Usually you would have a comma or several commas in your address. So in one way, the comma represents separating different values, but we want the address to be as one value. Okay, so this is a bit problematic, but we have a way to deal with that. We just use quotation marks to represent each and every value, and then use the commas to separate them. So the address will not be split into two or more, like because it has a comma in it. Okay, so that is the operation that is called escaping. Okay, again, using quotes to define separate or to define entities that should not be separated, even though they have commas in them. Okay, if the entire value appears in a quoted string, the address will not be split into. Let's talk about saving a CSV file. This is a simple operation, and most editing software editors and other softwares allow you to save directly in this format. So you can, if you open up a Notepad, for instance, you can save as a CSV file, or in Excel, for example, under the file menu, if you select Save As and then select CSV, in the Save As type field, you will save your information as a CSV. Of course, all your formatting information will be gone, but you need the data, not the formatting information. Okay, I will pause now and ask if you have any questions so far about API, about crawling, about CSV format. Any questions? None whatsoever?
No questions.
No questions, good. When we talked about pandas in the last lesson, you saw that data frames can be saved as a CSV using the two CSV function or method, and also you can read the CSV directly into a data frame by the method read CSV. Okay, so we import pandas as PD, and then we have a method called data is equal to PD dot read CSV with a file name. Another library that is used for CSV is called surprisingly CSV, and with this library, what we do is we import CSV. The methods are slightly different. What we do is with open file name .csv as CSV file. So we open the data slightly different, and then with the object CSV file, what we do is CSV. We use the method of this object, which is reader in this case, and so we will use CSV dot reader with the CSV file, and we define what is the delimiter, what is the character that separates our values from one another. Okay, so these are two libraries that work slightly different from one another, CSV and pandas. Both of them can be used to deal with CSV. Okay, slightly different, let's call it methodologies. After we familiarize ourselves with our first data saving format, it's time for us to get to know another and not a less popular format for this action, and this is called a JSON format. Okay, the name JSON, as I said before, is actually an acronym. JavaScript Object Notation. Okay, JavaScript JSON. How many of you are familiar with JSON? Please raise your hand or chat or whatnot. Let's see. No one? So you're not familiar with JSON, so we'll have to go a bit more deeply into that, no problem. The main use of JSON is to transfer information between systems. through the internet, through your computer, whatnot, through different systems. The reason for the popularity of the JSON format is due to the part that it makes it possible to move relatively complex structures. Okay, you can see that these are more complex structures than a CSV, than the tables in CSV. It is easily readable by a human being, okay? And the elements within it are presented in an understandable and effective way. So let's understand what the JSON format looks like. Here is an example of a response from a Google Finance API, okay? This gives us a quote on a stock, on a share of a stock, okay? For Google in this case. After I ask the API for some information about the stock market, we have the whole opening element, okay, which is the query, and below it we can see the query bar, which is our request for the relevant data. So we have after the query we have count one, so how many shares did we ask the price for? The created, when was it created? The language, English USA, and the results. And now you can see that within the results, we open one more section. So we go down one level. Now the results are the quote, okay? So maybe this is in your way, perhaps. Okay. So what are the results? I said the results are the quote, and we have one quote, right? Because the count is one. And what that quote is, what is that quote? We have the symbol of the share, which is GOOG, which is Google, obviously, the asking price, the average daily volume, the bid, the ask real time and the bid real time, which we got null values, the book value, the change, the percent change, and the change itself, okay, and so on and so forth. We'll have a lot of data there. So this allows us to have a much more elaborate and let's say complicated data transfer, because this is not just a table. This is basically an object, okay, an object that has many hierarchical levels. Each level contains another level within it, okay? So let's expand a little more on our format. The JSON format is made of orderly pairs of key and value, as you saw, okay? So an example of a JSON object that contains, for instance, course information, okay? So first of all, a key is always displayed as a string inside quotes, okay? In this case, the course name, for instance, okay? And the value, in contrast, can be a string, a number, a Boolean expression, or in itself a list or an object. The orderly pair, or the ordered pair, created for us is the two objects together, okay? And between them, there is always a colon, and a comma that separates each pair and pair. Okay, you understand? So it's basically like a dictionary, like a sophisticated dictionary, okay? If we said that a CSV is like an array or like a data frame, then a JSON is like a dictionary, okay? Any questions so far? From Tashkent or
No questions.
from Baku? No questions. Good. Thank you, Amanova. You're very helpful.
Thank you, teacher.
So it is important that we understand how Python helps us write or read JSON objects, and that's exactly what we'll see next. So the module or the library that help us read and write objects from the JSON is called a JSON, okay? Not surprisingly. So it has two main functions, JSON dumps and JSON loads. When I say dumps and loads, it means it dumps a string and it loads a string. Okay, so what the two functions actually perform are the same operation, but in reverse. That is, through the first, we can take a Python object and turn it into a JSON string. Okay, and in the other one, we take a JSON string and turn it into a Python object. Okay, so obviously this is very important. Let's go back to the example of the information object of the course that we saw. Okay, what do we do? So in Python, we define a dictionary called data. Okay, you can see that it's a dictionary because it has curly brackets, right? This is how we define a dictionary, and it has pairs of key and value, as in any dictionary. So course name will be Intro to Data Science. The number of students will be 53. This is not your course. Your course is 30, but the last course was 53. The grades average is 87. Again, I hope that your course will attain that average. It's already started, and so on and so forth. Okay, and the instructions are the instructors are instructors are another level. Okay, of data hierarchical level. So we have a name, which is the Professor Israeli, and affiliations, which is AHAT, and the ID 1, 2, 3, 4. Okay, I don't want to give real names, obviously, for privacy reasons. So once we define this dictionary, what do? We create a JSON string that simply uses the dumps or dump-s method from JSON to take this dictionary and make it into a string, into a JSON string. Okay. Now, this is not enough because okay, we have the data as a JSON string, but we want to save it as a file, right? This is basically this is the main goal of our main goal is to take the data and save it as a file. So we take the JSON library and we use a very similar method to the CSV library, meaning we do the following two commands or following group of commands with open data.json, comma w means we want to write. This is a file for writing. As f is the name of the file in our system. Okay, the name of the file, I mean the object, the name of the object that represents this file. And then what we do is JSON dump. Now it's not a dumps. Dumps is to dump into a string. Now we want to dump the data into a file. So what we do is JSON dump, not dump s, the same data that we defined as a dictionary, but now we put it into not into a string, but into a file f, which we opened up before. Now, if we want to read this data, what we do is again the same. We use this a very similar a set of commands, but now with the open file data JSON, now we use R instead of W, which means read instead of write. As F, same name of file, doesn't matter, but we can use the same name of object. Now data equals JSON.load of F of this file. Okay, very simple, very straightforward. Okay, and now if we want to take this data, for instance, now it's basically a dictionary, so we can write print data square brackets grades average, and we get the number 87.23. Right? Everything is understood?
Yeah.
Good. Now all of you know how to save data. Now it's time to teach you how to do magic online. And that magic is how to acquire data. In this lesson, we will learn about APIs. what it consists of, how to use it, and how to consume data through it, how to acquire data through it, to be honest. Many companies are interested in us being able to use their data. And for this purpose, they expose their data to the general public. Let's say Twitter does that, Google does that, Weather Channel does that, Stock Exchange does that, because they want to make the data available to the public. Okay, this is what they do. This is their business model. Okay. This is often large amount of data. So to get this data, they don't want you to start poking around in their databases. What they do is they provide you a programming interface that the company builds for us, okay, to get the data. This interface is called API, or Application Programming Interface. And there are many companies that have APIs, as I mentioned before, Twitter, Google, the stock market, the Weather Channel, and so on and so forth. One of the challenges in data acquisition is that sometimes the sites and sometimes the APIs that you acquire data from may vary. So, for instance, Google may say on one day we upgrade our API and we have more features, okay, and we deprecated the other features. So this challenge can cause the system that was built by you to abruptly stop working. Suddenly it stops working because the other party has changed their API. Maybe they publicized it that they changed the API, but you didn't notice, and suddenly your application or your system stops working. Okay, and this, to be honest, happens all the time. So we must build our APIs in a way that is resistant to change as possible. It is robust. Okay. So an API is a servant-to-client communication protocol based on internet communication and on directories, commands, functions, and procedures that we get ready-made for us by the company that is publicizing the API. Data scientists and other people as well, which are basically the various customers, can use this interface to acquire information from various sources. The only condition is that the source will be interested to share the data and will reveal addresses and reveal the API. Okay. Many of the data consumption APIs are written in REST API format. This is a very standard format, and they make use of URLs, or rather URI. URLs are, of course, uniform resource location. URI are uniform resource identifier. Okay, that's the difference between URL and URI. For example, in this case with Twitter, if I want to get tweets from Twitter, I can access the API in this way. Okay, and what you see on the screen. What we see is that we have the address of the API, and that is https://api.twitter.com. Okay, and then there is an ID of the version 1.1, and then the action itself: search tweets.json and the query Q question mark Q, which means the query, and Twitter API. Okay, it's important to say that companies occasionally change their APIs, so that when you run this example, the API will be different, and you will need to make changes and adjustment to your system. Okay. With an API, we're basically addressing a remote address in a programming way, to get the information. Let's see an example of what such a request looks like. So what this code says, what this code does, and once we turn on the computer, we go into a space station cell. Okay, so this is the International Space International Space Station. We use the requests library, which is a standard library that comes with Python. And this includes functions that help manage HTTP communication. Let's see how such an address is analyzed from left to right. So this is first of all, of course, we import the library, import requests, okay? And this is the technical HTTP protocol that we use. HTTP is the acronym for Hypertext Transfer Protocol, which is the standard. Most often this is the standard, but not always, because as you've seen earlier, there is HTTPS, which is similar, but a more secure protocol. Okay, so Twitter uses HTTPS, but the International Space Station uses HTTP. Now, API opennotify.org is the server address, okay? In this case, the space station, but later we will also see Twitter address. After the slash, we see a part in the path, okay? This section sometimes indicates a location within the site or server, and sometimes indicates a function name on the server. What does this function do? It gives us back the current location of the space station in JSON format. Okay, ISS now gives us the location of the International Space Station right now, at the second that it gets this request. Okay. Now you see that we are using the get method. Okay, when we call the get method with all this URI, we're actually running the ISS now.json function. So after we understand how to call the API, how this call is structured, let's run this code and see what happens. So I thought that even though we think that we would get the location, instead what we got is a text back that says response 200. What does this mean? This text is an indication that our request has reached the server. Okay, it actually means that everything is fine. Response 200 means everything is fine. There are all kinds of codes of this kind, like 200 in this case, that you should know. And there's a table that contains the main one. I'm sure that one of these codes, error 404, most of you are familiar with. This is an error that you get when trying to access a non-existent internet address. Now let's see the responses that we can get. So 200 means everything went okay and a result has been returned. 301 means the server is redirecting the user to a different endpoint. Okay. This can happen due to changes in domain name, for instance. Oh, okay. 401 means that according to the server, the user is not authenticated. We'll see later what it means to be authenticated. This can happen if the user sent the wrong credentials, okay, to the API. 400, this means a bad request. So you get to the server, but you are sending the wrong data, the wrong request, the wrong format of request. This can happen, for instance, if the API changed, as we mentioned before. 403 means that the resource the user is trying to access is forbidden. You don't have permission to access the resource. Okay, someone else that you don't. Your credentials does not allow you to access this particular resource. Other people may have this may have authority, but you do not. And 404, which all of us know. The resource is not found on the server. This is very common. Any questions so far?
No questions.
No questions. Thank you, Amanova. No questions. So you're the representative of the classroom, right, Amanova? Never mind. Okay, good. So now we have a representative, and I can discuss directly. That's very good for me. So, as you may have noticed, before making the request, we call the get command or the get method. Okay, what does it actually say? So REST API, again, this is the standard API format, has 4 types of commands: delete, post, put, and get. Okay, each of which is intended for a different type of action. Get, the purpose of get is to get data, as its name implies. Okay. Post, its purpose is to upload new data to the database. Put means update a particular statistics, and if that statistic does not exist, create it. And of course, delete deletes a certain data. Obviously, usually we will not have permission. In many cases, we will not have permission to put, post, or delete. Sometimes we do. It depends on the API. It depends on our credentials. But we will usually have access to getting data. So mainly we will use get to get the data that we need. Now, let's remember that when I ran the command earlier, I received a response saying 200, right? Response 200. It was the code that the computer returned that everything was fine. But that's not the answer itself. That's not the data that I want, right? So what do? I look further into the response, meaning I look at the response content. The response has an attribute called content. And I look into the content of the response. And if I look at the content of the response, what I get a string saying ISS position, colon, curly brackets, latitude, colon, minus 48.1607, comma, longitude, colon, 70.4640. And then curly brackets, and then I get a message, which is success, and timestamp, which is 158.426.5527. We will see later what this means. So what is this string? Can someone answer for me? We saw that earlier. What is this format? Anyone? Nechim?
This is a JSON?
Exactly. This is a JSON string that we've seen earlier. So, and if we want to double check that indeed we got a JSON, what we look is the headers. The response has a content, but it also has headers. And we look at the content type of the headers of the response, and we get application/JSON. Okay? So this confirms what we thought. What the data that we get, we indeed get a JSON or JavaScript online notation. So let's move on and let's see how we can decode the JSON answer. We will set the response.content.decode to UTF-8. UTF-8 is one way of decoding data. There are several ways, but this is the most standard one. We will run this command and expose all our content. If you want to present the details in a slightly more aesthetic way, we'll get something that looks like this, okay? And if you notice, we got a result which is very similar to a dictionary, right? Basically an object with key value pairs, which allows us to use JSON's library to make it into a Python object or dictionary. So how do you do that? We will start and import into a JSON module. We will create an object called response _d, because this is the response in the format of a dictionary. And we call our function JSON load s to response _j, which is the JSON object we got. We will print the type of response _d, and it seems to be our dictionary. And so we can print the object and even access the various elements, since it is now a Python object, a dictionary, right? Let's run it and see what you can get. I'm sure that you can probably imagine, or actually can see it on screen. We get two values or a dictionary with two keys and two values: latitude minus 48.1607 and longitude 70.4640. Okay, so this is the data that we wanted in the first place, right? The latitude and the longitude of the International Space Station. Now, pandas can load JSON objects as well. It even simplifies our process. So how do we do that? Very simple. We import pandas, okay? And we call the command read JSON, read_JSON to our JSON object. We will run everything, and now what we get, you can see our data frame is presented in a very clear and orderly manner with all the details relevant to us, right? Very aesthetically pleasing. A very nice table with the latitude and longitude, but it has some data that we actually, I'm not sure that we want. Okay, what we want is data that is not necessarily aesthetically pleasing, but easier for the system to further process. Okay, so our answer now spans two lines. First line latitude, second line longitude. This is not what we want. We want one line that indicates the request time, whether it was succeeded, and what are the longitude and latitude in one place. So let's see how to do that. So we define a function that flattens the response into one line or into one dictionary. Okay. So this is an auxiliary function that's called flatten. The function will get a dictionary object of the response that we got and make a few minor changes to that dictionary to make it more convenient for printing and working on and so on and analyzing and so on and so forth. Now, what the function does, it examines the internal dictionary of the ISS position and increases the value of, or raises the value of latitude and longitude to the first and basic level. Now, the second thing is it deletes the ISS object of the ISS position. So now if we call the function flatten on the response that we got, we'll get one dictionary, a flat one, that contains all the data that we wanted to extract, right? The key message saying that we got a successful response, the timestamp, the latitude and the longitude. Each one has a value. Okay. Now let's put everything together. Let's define a function called pool position. This actually invokes the API, accepts the results, loads the JSON into a dictionary, flattens it by removing the inner elements, and returns the flat object all at once, all in one function. Okay. Now, one more thing that we want to show the time, not in the format that we've seen, like a long number that means nothing to us, but we want to convert it into a date and time that we can read. We as humans can read. So we also import time, the time library, which allows us to do that. So what do? We retrieve the position of the ISS. So we use the request.get method, and we store this in an object called response. Second thing, we make another variable called response j, which decodes it into a JSON string. A response underscore d, which is a dictionary, which loads the response j, the JSON string, into a dictionary. We flatten it, okay, using the auxiliary function that we defined earlier, and we store that into an object called flat response, and we return that object flat response, that variable. Now, what do we want to do? Let's call this function 10 times with intervals of 3 seconds between them, okay? So what do? We create a loop for I in range 10, so we run it 10 times. We use the pool position function. We use flat response equals pool position, and then we append this into a list called ISS positions. Okay. After that, all we have to do is sleep for 3 seconds. Okay, so time allows us time has a method called sleep, which waits for 3 seconds. Okay, so in that way, we make 10 requests to the space station, API, with 3 seconds intervals. Is everything understood so far? I think it's very straightforward and very understandable.
Yes, it's understood. Thank you.
Good, thank you. So now put everything together. Now let's take the data that we received and put it into one data frame, because we want to analyze the locations of the stations of the space station. Okay, so we will perform the following steps. We will create ISS position DF, which is the data frame of the space station location. Given the area as a parameter to the data frame, the function is called PD2DateTime. Okay, so pandas 2DateTime, and now you can see the timestamp, longitude and latitude. Okay, so as I said, now we can see the timestamp not in a computer format, but in a human format. So we see the time and date that each request was sent to the ISS. So that's June 15th, 2020 at 8:47:48, 8:47:52, 8:47:55, and so on and so forth. All of them were successful. Okay. And in all of them, we got the latitude and longitude of the International Space Station. Okay. Now, the last step is visualization. I want to visualize the results. I want to see the position of the International Space Station on a graph, in a graphical way. So I'm using Matplotlib. We've discussed Matplotlib in last week. I told you that this is one of the tools for the data scientist, one of the libraries that we use. We didn't go into it yet, so I'll just show you an example. I will not go deeper into it. We will study it later in this course, but in the moment I'm just showing you an example. So I'm just using the codes for visualization. Pandas have a built-in graph plot method. The data frame has a built-in graph plot method that we're using here to visualize the latitude and longitude of the space station over 30 seconds. Okay, so we can see the latitude in the x-axis, the longitude in the y-axis. Okay, and this is a scatter plot. A scatter plot means that we see points in each time step. Okay. So you see the data frame itself has a method called plot that we use to show its content in a graphical way. This is visualization. Any questions so far? Okay. So far, we've learned about two types of open APIs that the access for is free. Okay. Both Twitter and the International Space Station. If we try to classify the APIs into classes in terms of the possibility to access them and get data from them, you can think about 3 levels. Okay, the first level of an API is an open API, which is what we've seen with the International Space Station. It has a very defined type of answers without any parameters. We didn't send any parameters to the to this resource. We just got we can only get one response, which is the longitude and latitude of the space station. We don't give any parameters. This is similar to, let's say, a chewing gum machine in which you put a coin and you get a chewing gum. You cannot choose between a red chewing gum and a green chewing gum or whatnot. You put a coin, you get one type of response. Okay? The second level is API with parameters, or parameterized API. In this API, we need to explain to the interface what we are asking for. And we give parameters that we want to be treated. This is similar to a drinking machine. Okay, a soda machine that you put a coin and then you define what kind of soda or what kind of drink you want to get. So if you want to get Coca-Cola or Pepsi-Cola, or if you want to get orange flavored drink or lemon flavored drink or whatnot. Okay, so this is an API with parameters. If this was the type of API, we would for instance, go to send a GET request to the space station. We would give it a parameter our location. Okay, let's say we have let's say the space station has an API saying when will the space station be exactly above your location. Let's say I want to see, because I have a telescope and I want to see exactly when the space station is going to pass over my head. Okay, so I will need to provide the API with the parameter, my location, where am I? In that case, so that the API can give me an answer. The next time the ISS, the International Space Station, is over your head will be in 2 hours, for instance. So this will be a parameterized API. I need to give it my location. The third level is an API with parameters that also requires identification or authentication. Many APIs, or most APIs, are third-level APIs. This level includes the two characteristics of the first two. In addition, I need to send an element of identification. This is similar to an ATM machine, okay? The first thing I do when I go to an ATM machine is where I get money, all right? So obviously the first thing I need to do is to identify myself and make sure that I'm allowed to receive money from the ATM. So the first thing I do is identify. And only that, then I choose the action I want to perform, right? To withdraw money, or to do any other type of, or just to look at my account and see how much money I have there. But the first thing I need to do is to identify, and I do that with a card, with a credit card. Okay. Why do you think that there are APIs that require a process of identification and checking your permission? To be honest, there are so many reasons why we need to identify. The first reason is the protection of our information, right? Same as an ATM. We want to make sure that not everyone can access your information, but they can only access their information, okay? Or if they have permission to get other information, that's okay. But we need to know who this person is and what the kind of permission that they have. One more thing is that we want to make sure that no one accesses information that is not his. Okay, and another reason relates to the different services level. Okay, different users have different service levels. There are those who can make many inquiries, for example, and those who have few. In this way, the system can control or regulate the activity for private entities or for a company or for a business entity, okay? The last reason is tracking violations. In case of improper use, such as a hacker or misuse of the rules, the system can impose sanctions and block the user from continuing to use it, right? If someone tries to access someone else's bank account, we want to block him from accessing the system at all, because at a certain point he will try, and then at a certain point he will succeed. We don't want to do that. We want to be able to regulate this user, and at a certain point, if what he does, we see that this is wrong, we need to be able to block it. Okay. So, what is the difference between identification and permission, or authentication and permission? Authentication is the first step in connecting to the API, a stage where the API recognizes the user, usually by a username and password. All of you have done this many, many times. The username tells him who I am, and the password is meant to make sure that who I say I am is really me, and I do not lie. Okay. Now, permission, on the other hand, depends on the user, on the type of permission that the user has. The API knows what data it can transfer to us and what data it cannot transfer to us. Usually, business entities, for instance, have different permissions than private individuals. Okay? Everything understood so far? Any questions?
No questions. Everything understood.
No question. Good, thank you. No, this is not what I wanted to do. Just a second. Okay. So let's see a brief explanation of what Twitter is. For those who do not know, I'm sure that most of you, as I've seen, most of you are young people, so your generation probably knows what Twitter is. But for those of you who do not know, maybe one or two, but I will still say it, Twitter is a social network that allows people to share tweets. And tweets are short messages that have friends in it. Members can see their friends' posts and also respond to their messages. Okay, an example of a structure of tweeting can be seen here. Okay, here we see the username, the comments, the date, the time, users who tag them, and the subject tagged in hashtag. You can see also user comments, likes and shares. What you see here is one tweet. There is one user post here that appears in the bold section. Now let's see what can we learn about the user from this post. We can see when the post was created. We can see the username that wrote the post and the location from which the post was written. Okay, the geolocation, the location in terms of the longitude and latitude. And of course, lots of other parameters. Now, to identify, we usually need to provide an API username and password or key and the like. It is very important to remember that even when we do this in code, that the key and password remain confidential and no one will be able to see it. I will soon illustrate this subject to you as well. For this purpose, examples are made with the Twitter API. Python has a lot of directories that connect to Twitter, or libraries that connect to Twitter. We will use one library, which is also popular and also very convenient. And this is called Twython, so Twitter Python. Since we use the Twython library, we'll no longer have to use the request library because the Twython library incorporates the request library inside. Okay, so it will actually pass. Twython knows what the URI for Twitter is, so we don't have to pass that, and we can use directly Twython with our credentials. Okay, so here I have an example of a higher level API than request. So in order of course, in principle, we could use the request library, but we have a shell. Twython is a shell over, it encapsulates requests in it, so we don't have to use request. This simplifies the approach for us. So we don't have to code so much. So we have direct access from the Twython API to the Twitter API. So the first thing to do in order to use that, because this is a not built-in library of Python, is to install Twython, and this is done with the command pip install Twython. Of course, if you use an IDE locally, you will write pip install Twython. If you use a notebook such as a Jupyter Notebook or a Google Colab, you will have to precede it with the percent sign. So percent pip install Twython. Okay. So this is the first thing you do. The second thing is you need to obviously open a Twitter account, because when you open a Twitter account, you get a user and a password. You get your authentication code, which you then store in a file, and you have to make it confidential. You have to keep it a secret, but you can use this file. You can use the key, and the key comprises two main elements: a consumer key and a consumer password. Okay. So to get that key, of course, you need to connect to your Twitter account and take the key and password, and you store those values, and now you can use them you can use them with the Twython library, okay, that you imported. You import the method Twython itself. So from Twython, import Twython. Once you opened up a Twitter account and got the key, you can use that as the key, okay? So you get a consumer key and a consumer secret, and you use the Twython function to get the tweet, okay? Good. Any questions so far? So we have 15 more minutes. What I want to do, with your permission, because we in the last lecture we didn't finish everything that we needed to finish in terms of what I wanted to pass. So I will use the last 15 minutes to complete what we were missing in the last section. Okay. So give me.
Okay.
Thank you.
Thank you very much.
Okay. So in the last lecture, as you remember, we talked about pandas, and we didn't finish because we didn't have all the time that I wanted. So I believe we ended in here, right? In how to view data, right? So we have several attributes of the data frame: the data frame index, the data frame's columns, and the data frame's values. And these are attributes. You can see, how do we know that these are attributes? Because we don't have parentheses around it. So if I want to see the index values of the data frames, I just use a df.index, and I get all the indices of this data frame. Similarly, if I want to get the names of the columns, I want to get the attributes df.columns, the columns attribute of the data frame, and I get the names of the columns. And if I want to see the values, very simply, I just write df.values, and I get all the values of that data frame. Did we talk about describe? I think not, right? We did not have the time to talk about describe. So if I want to get quick statistics for all of my columns, what I do is I use, now it's a method, it's not an attribute because it has parentheses, as you can see. So I use df.describe with parentheses, and what I get is the count of rows in each, or count of values in each column, the mean, the standard deviation, the mean of the average, the standard deviation of the values, and all the quartiles. So the minimum value, the maximum value, and the quartile. So the first quartile or the 25th percentile, the median or the 50th percentile, and the third quarter or the third quartile or 75th percentile. Okay.
Okay.
If I want to sort, Pandas allows me to very quickly sort my values, either my data frame, either by the index or by the column. So either by columns or by rows. So in this case, I want to sort by index. Axis equals 1. So this is by column. And I want it descending. So I write ascending is false. If I write ascending is false, obviously this is descending. So now this will sort the data frame in a way that this is arranged by the index or by the date. So I get January 1st, the first row is January 1st, then January 2nd, 3rd, 4th, 5th, and 6th. Now, if I want to sort it not by the index, but by the values, I use another method called sort values, okay? So data frame sort values, and I write by which column I want to sort them. So in this case, I want to sort them by column B. I will get, and now you can see that in terms of the dates, now I have January 3rd, then January 4th, then January 1st, January 2nd, 6th, and 5th. So this is not sorted by the index, this is sorted by the value of column B, right? So I have minus 2.1, minus 0.7, minus 0.28, minus 0.12, minus 0.1, 0.1, and 0.5. Okay, so this was sorted by the values of column B rather than by the index. Selecting a specific column, okay? So and I select selecting rows. Now I select a certain row, not a certain cell. So I select by the label. Okay, so I use location with dates 0. So the first row, I just want to see the first row. So then the first row is of course January 1st, okay, of 2013, and I get I get a series of all the values by column. So A, B, C, and D. This is location. I can also use multi-axis. So both rows and columns. For instance, dfloc, the same method, loc, location. Now I use colon. If I use colon, that means I want all the values. Then comma, and then a list of two column names, A and B. Okay, so now I get all the values of just the columns A and B, but with all of the rows. Why? Because I use colon. Colon means all of the range. Colon without a number or a label preceding or superseding it means everything. If I just want certain rows, what I do is I slice. Okay, with slicing, unlike Python, in Pandas this includes the last value. So again, df.log, but now what I'm saying is I want from January 2nd to January 4th, including the first and last values, because again, Pandas includes the last one, unlike Python, and also comma, and now columns A and B. Okay, so I can also slice I can slice ranges in both the index and the columns. Now, if I want to select by position and not by the index, what I use is iloc. Iloc meaning integer location. So now instead of saying I want to see the row of the 4th of January, I write iloc and then number 3. You remember that in Python we start with 0. So number 3 will be the 4th row. So if I want to see the 4th row, I will use the df iloc 3, iloc instead of loc. So iLocation or iterated location instead of location. And again, I can also slice in multi-axis. I can also say df iloc between the 3rd and 5th rows, and between between the 4th and 5th rows, because you remember that we start with 0. So 3 will be the 4th row. So I just want the 4th and 5th rows. Here, the last one is not included. And I just want the 1st and 2nd columns. Okay? So I can slice, with iloc, I can slice again in 2 directions, in 2 axes, the row axis and the column axis. Boolean indexing. Now I want to see all the values that are larger than 0. Okay, so I can use Boolean indexing, saying, show me the values, only the values that are larger than 0. Let's look at the values here. So I can see that some values are positive, some values are negative, and I want to see only the positive values. So what I do is I put a Boolean condition saying, give me only the values that are larger than 0. And the way to do that is to say df, or the data frame, square brackets, same name of data frame is larger than 0, or smaller than 0, or 0, whatever condition I want to put, or equals to 0, whatever condition I want to put. And what I will get is the values, only the positive values, or only the values that answer my condition. And the values that do not answer my condition, I will get an NaN. NaN is not a number. Not a number is a special code in pandas that means that this is not a number, and every statistic that I will use will not include this number. If I just put 0, I will lower the mean, I will lower the standard deviation. I don't want to do that. What I want to do is everything that does not answer my condition will get a NaN, or not a number, value in it. And of course, if we will see ways how to, if I do want to make it into a 0, there are ways to do that. We will see that later on. So one more thing to remember is that if I want to make a copy of a data frame, I cannot simply say one data frame is equal to the other data frame, because then both of them will point to the same data frame. That is not what I want to do. I want to create a copy of the first data frame and put it as a second variable. So I will do a very important method called copy. So the second data frame does not, I will not write df2 equals df, but I will write df2 equals df.copy. This is very important to remember. Okay, you want to create a second copy and work on that. So I create a second data frame called df2, which is a copy of the first df, and then I add one more column. You remember data frame 1 had only 4 columns, A, B, C, and D. I add one more column, E, and this will have strings, not numbers. 1, 1, 2, 3, 4, and 3. Okay? And again, I can use Boolean indexing to see that which values or which rows only have the strings 2 or 4 in column E. So I will use df2 square brackets again, df2, the same name of the same data frame, but now I slice it just to see E, just to see the last column. Is in means that the value in there is in a certain list, and that list contains, in this case, 2 and 4. Okay, what I will see here are only the rows in which the value in column E was either 2 or 4. Okay, so that's the 3rd of January and the 5th of January. Okay. Any questions about this, the additional functions we saw in pandas? I still have some more things to show in pandas, but this will not happen. Every time that I have some spare time, I will go back to this lecture and continue to show you more methods in pandas. Any questions about the new methods we learned in pandas, or any questions about data acquisition, about APIs? None whatsoever. So I will thank you very much. As I promised at the start of the lecture, instead of giving 45 minutes, then 15 minutes of break, then another 45 minutes, we did one session of an hour and a half. This is what the students who were present at the beginning preferred. So I will say thank you to all of you. It was a pleasure. The lesson was a pleasure, as always. And I will see you again next Thursday. If someone wants to stay with me and ask a question, now is the time. Otherwise, everybody else are free. Thank you so much.
Thank you, sir. No questions about you.
Good. Thank you, Ruslan. Just one thing before everybody goes. I didn't see anyone submitting any exercise, any Vocarium exercise. Did you all get messages from Vocarium about your assignments? Because I haven't seen anyone submitting any assignment whatsoever. All of you got, did anyone not get an email from Vocarium saying, this is your assignment, please go and do it? They should be
actually,
automatic.
I have a question about that.
What, sorry?
Because I went to the Moodle and I have a home task, but I don't understand what we do with that. Because
so there are two systems. One system is the Moodle system, which only contains the materials, the lecture materials and the videos and the recordings. But there is also a system called Vocarium, which I registered. I got the names and emails of all of you, right? And I enrolled all the students in Vocarium. So you should be getting emails from Vocarium, from Vocarium system, saying you are enrolled to this class and please do this assignment and the due date is so and so. You're not getting any emails like that? No one is getting emails? Did someone get emails?
Actually, it's on that system, but I forgot about that.
Okay, so again, your exercises for submission are not on Moodle, they are on Vocarium. And you should be getting emails from Vocarium saying this is your exercise. So I understand that there's a problem. I will ask the administrators to, first of all, to make sure that all of you are getting emails. And of course, I will postpone the due date by 1 week so that everybody has the chance to do the homework. But please go to your emails and see that you're getting emails. And if you have a problem, you have my email on the Moodle, and send me messages that you did not get the Vocarium messages, and I will make sure that you are able to do your exercises, because your marks are based on that. 66% of your marks are based on your exercises. Okay, so it's very important that look in your emails, maybe it's in your junk mail, I don't know, maybe the spam filter that, but make sure that you get the messages from Vocarium and you do your exercises. Okay, so I will end with that. Thank you all. Have a nice day.
Okay, thank you.
Good and good studying. Bye-bye.
Bye-bye.
Bye.
Goodbye, thank you.
Thank you. Good day.